Okay, so now we're going to take a look at another word problem. This time you'll notice that we're working with a decreasing percentage, and we will use what's called a decay factor in this case. And so you can see the equality 1 minus r is the decay factor. A lot of times whenever we're talking about a car or a piece of equipment or some sort of asset that a business has, we call this depreciation. So you may see that word from time to time. So go ahead and work sample problem number 5 here and take a look at the solution. Okay, so it says to write an exponential model for the value of the car. Again, we're going to just use the same model we did before, except this time with a decay factor. We had an initial amount of 24,000, now 1 minus the decay factor, 0.16 raised to the t value. As always, you should condense this and not leave it with the operation. And so that is your decay model. Now, it said to see how much the value is estimated to be worth after 2 years. So again, simple plugging in of 2 years for t, and you can see that that value equals. Now we want to graph the model, and of course a simple little t-chart here will help us do this. And again, negatives would be kind of irrelevant at this point for this type of model, and so we will use a quadrant 1 of the graph. And so if I just created a simple input output, and so if we graph this, and you can start to see this declining deal, and it would hit that asymptote, it kind of start to level off a little bit. So the value of the asset would never actually go fully to 0. You could always scrap the metal of the new car and get some money out of it, so it doesn't actually become worthless at any point, and that's what the asymptote is showing us. Now, part D is asking us to estimate the value of the car being $12,000. So you can see somewhere in here, $12,000 kind of works its way somewhere between year 3 and year 4. So we could simply say about right now year 3 would be an appropriate response. Now, when we move into logarithms will give us a more exact way to come up with that value, so we don't have to approximate it off of a sketched graph.